Analysis and Design of Algorithms Laboratory, Program 1. Design and implement C or C++ program to find minimum cost spanning tree of a given connected undirected graph using Kruskal's algorithm. So before getting into the program, let's see what is a spanning tree, what is a minimum spanning tree, and how Kruskal's algorithm helps us to find out minimum cost spanning tree. A spanning tree is defined as a tree-like subgraph of a connected undirected graph that includes all the vertices of the graph. So for a given graph, we design a or we find out the of the subgraph of that given graph which is a connected. So such kind of tree or such kind of subgraphs are called as a spanning tree. A spanning tree should never be cyclic, then only it is called as a spanning tree. A subgraph can be termed as a spanning tree. The minimum spanning tree has all the properties of a spanning tree with the added constraints of having minimum possible weights among all the possible spanning trees. So for the given graph, we can find out n number of subgraphs, means we can find out n number of spanning tree. So a minimum spanning tree for a given graph or for a given spanning tree where the weights of the sum of all the weights of the edges should be the minimum among the all other spanning tree. So such kind of spanning tree are called as minimum spanning tree. So here in this example, we can see that the graph towards the left side, it is a directed graph. Or if we are considering an undirected graph, then edges will not have any arrows. And these are the weights of the graph. So here we have three vertices, 1, 2 and 3 and 3 edges. For the given graph, we find out the subgraph. So subgraph where it should contain all the vertices, but it should not contain a cyclic edges in a cyclic manner. So such kind of trees are called as spanning tree. If it is cyclic, then we cannot term it as a tree. So this particular the graph towards the right side satisfies the spanning tree condition. So a minimum spanning tree is defined as a spanning tree that has the minimum weight among all the possible spanning tree. So the properties of the spanning tree lies such that the number of vertex v of the graph and the spanning tree is same. So here in this example we have three vertex, and even in the spanning tree also we have three vertex, and the fixed number of edges in a spanning tree is always equal to 1 less than total number of vertex. Means we have three vertex here, so the number of edges in the spanning tree will be v minus 1, means 3 minus 1 is nothing but 2, so it is 2 edges we have. So it is a minimum spanning tree. The spanning tree should not be disconnected. So here all the vertices are connected, so it satisfies the third rule, and the spanning tree should be acyclic. So we there doesn't form any cyclic in this particular tree structure, so it is a spanning tree. So spanning tree properties have been satisfied. So minimum spanning tree is nothing but which has the minimum weight among all the possible spanning tree. And Kruskal allows is one of the algorithm which allows you to find out the minimum spanning tree. So how does Kruskal provide you? It uses a greedy algorithm. For a connected undirected graph, first we sort all the edges of a graph by their weights, and then we start iterating finding the spanning tree. At each iteration, the algorithm adds the next lowest weight edge one by one such that the edge picked until now gets does not form a cycle. So here for the undirected graph is given in this example. So the number of edges here is 9 edges exist from 0 to 8. It is 9. So according to the condition or the property of a of a spanning tree is the number of edges should be v minus 1. V minus 1 in this case is 9 minus 1 is 8 edges should exist. And minimum spanning tree where it should have the minimum weight among all other spanning tree. So Kruskal considers first we should sort, we will consider the edge with the minimum weight. So here in this example, the edge with the minimum weight is the edge between 6 and 7. So we will consider the first edge and the vertex 6 and 7 in the first stage. Next is after 1, the weight 1, what is the next minimum weight or the least weight? Here we have between 2 and 8 or 6 and 5, any one of this you can consider. So 2 and 8, so we will consider next edges 2, between 2 and 8, which has the minimum weight. Next is 6 and 5, so we consider 6 and 5, between the edge between 6 and 5 has the weight 2, so we consider this particular edge. So in the next stage, the minimum, here the minimum edge after 1 2, we have 4 is the minimum weight, so we can consider 0 and 1 or 2 and 5. We cannot consider other edges, so here we'll consider 0 and 1, and in the next stage it is between 2 and 5, which has the minimum, the weight, that is 4. Next, in the next stage after 4, it is the minimum weight is 6. Here between the vertex 8 and 6, we have the edge with the weight 6, so we consider that in the next stage. In the next stage we consider that. But one thing we should consider here is, if we consider this 8 and 6, the edge 8 and 6 for this particular result, if we consider the edge, it will form a cyclic graph. So when it forms a cyclic graph, it violates the rule of spanning tree. So we will not consider this edge. So we'll move on to next particular edge. So here between 7 and 8 and 2 and 3, and here 7 and 8 we cannot consider. Why? Because it again forms a cyclic graph. So we will consider the edge 2, between 2 and 3. So 2 and 3 we have considered here, 2 and 3 here. So in the next stage we will consider the next after 7 it is 8. So between the vertex 0 and 7 or 1 and 2. So between the vertex we can consider 0 and 7 or 1 and 2. It forms a cyclic graph itself. So we will consider here the edge between 0 and 7 with the weight 8. Next, in the next stage we will see the minimum cost or minimum weight is after 8 it is 9. So 3, between 3 and 4, between 3 and 4 the weight is 9. So now next is 10, right? The weight is 10, we cannot use 10. Why? Because it forms again a cyclic. 11 also forms a cyclic graph. 14 also forms a cyclic graph, right? We cannot consider this edge, or we cannot consider this edge, or we cannot consider this edge or this edge. Why? Because it forms a cyclic graph, which violates the property of a spanning tree. So since we have traversed through all other edges, and we have encountered, we have come up with all other vertex that exist in the graph 0 1 2 3 4 5 6 7 and 8. So we have found out the minimum spanning tree using Kruskal's algorithm. So let's look into the program. Here we use header file hash include stdio.h, and we here we declare and initialize a variable of type integer, that is ne is equals to 1, and minimum cost initially will be 0 for that particular tree. So a minimum cost is nothing but the sum of all the edges in the minimum spanning tree will give you the minimum cost. We start with void main, and we declare variables n, I, j. N is nothing but to store the number of vertices. Ij is for the iteration purpose. Min is to find out the minimum value. A, u, b, and for the variables to find out the intermediate value and to compare. And then cost of 20 of 20 is then two-dimensional array which can store a maximum of 20 cross 20 matrix elements of a graph. And then parent 20, which stores the parent vertex value. Now print we ask the user to enter the number of vertices. Then using the scanf we store the number of vertices in the variable n, and we ask the user to enter the cost matrix. So using the for loop, since it is a two-dimensional array, two for loops have been used, one using the variable I, another using the variable j. So I is equals to 1 to I is less than n, less than or equal to n I plus plus till, and j is equals to 1 to j is less than or equal to n j plus plus. We scan all the cost from all the vertices, so which will be stored in cost of ij, row wise and column wise. Then for I is equals to 1, I is less than or equal to n I plus plus, parent of I is equals to 0. Initially we initialize a single dimension array, that is parent, which stores or which is initialized as initially as 0. Now printf, the edges of a spanning tree are, we print the heading, the edges of a spanning tree are, while any is less than n, means any initially we have initialized to 1, so any will be less than 1, less than n. N is nothing but the number of vertices. So ne will be less than 1. So min is equals to 999. We initialize to 999. For I is equals to 1 to I is less than or equal to n I plus plus, and for j is equals to 1 to j is less than or equal to n j plus plus. If cost of ij is less than min, if the cost of the graph in the matrix cost matrix is less than min value. What is the min value we have initialized initially? 999. So if it is less, then the new min value will become the cost of ij. So cost of ij, if it is 10, so 10 is obviously less than 999, so minimum value will become at that point as 10. Now a is equals to u equals I, and b is equals to v equals j. Means here you are setting up the to identify which particular node we are traversing, and the vertex and the edge we are traversing, that is the source and the destination at that point of time. So we initialize it to that particular node at that particular vertex. So once we are done with all the vertex and edges and identifying the minimum value which will be stored in the u and v index, while parent of u, while parent of u means it has some valid data, it is not 0. Initially parent of I we had set to 0, means whenever the minimum value, whichever edge is minimum value, only those parent of u value will be initialized, rest and all will be 0 itself. So parent of u means it has a valid data, not a 0. So u is equals to parent of u, we initialized u is equal to parent of u, whatever the value that will be stored in parent of u, that is the minimum, the edge that has to be stored will be stored in u. And then while parent of v means again there is a valid data in the parent of v, not a 0 value, then parent of v, whatever value was stored in parent of v, the edge index whatever was stored will be stored in v. Now if u not equal to v, if we, if u not equal to me, v means the vertex 1 and the vertex that, sorry, the vertex u and vertex v are two different vertex, means the edge exists there. So we print edge equals what is the edge, which is, and we print which will be stored in a and b, which we had initialized here, right, a and b. So that value, the cost of the edge will be uh, printed here using the minimum variable. So minimum cost is equals to the minimum cost plus the minimum value of that edge will be added again for the next time when it is called again, the minimum cost reinitialized with the new minimum value will be kept on adding, so that we find out the sum of total edges of the spanning tree. So that is the minimum spanning tree. And finally cost of AB equals cost of AB. So whichever cost that has not been minimum or which has not been initialized will be initialized to 999. Then finally we print the total minimum cost, which was found out here in the minimum cost will be printed using printf minimum cost is equal to min cost. Thank you.